There are a couple of other useful things that can be added to the schematic. The first is to name the actual nodes, the wires themselves. That's useful because when you come to ask the simulator to produce some output and plot some graphs, you can refer to these nodes by name. You do that by doing place, connectors, small terminal. You can use a big terminal, but big terminals are huge. I prefer to use small terminals. Select one of those and put it somewhere like, say, up there. And then wire it up. Actually, probably the first thing to do on that is to rotate it so that the name doesn't get obliterated by the wire. Wire it up to this wire here, and we'll have another one of those. We can just select it and duplicate it, move it over here, and then I can name these. If I select this item here and call it VB, the voltage on the base, and select this one here, and I'll call that VC for volts on the collector. I can do a similar thing, calling this V in and this V out. I'll just do that as well. Grab one of these, duplicate it and stick it down there, and duplicate another one, and put it over here, but this time I'll flip it and put it there. And then I'll call this one V out, and this one V in. Right, so I've now named all the nets. We've got ground down here. Actually, I haven't named this net up here, but since that's 15 volts all the time, it's rather boring, there's not much point. I've named V in, VB, VC and V out, and I can refer to them by those names from now on. Next thing to do, it's often useful to be able to see on the schematic itself what the bias conditions are, what the voltage at the base, the voltage, the connector, the current going through the transistors are. And Simetrix allows you to do that by adding to the simulator, things called bias annotations. Place marker. I can put one of those, say, down there, and wire it up to VB, the voltage on the base. And then I could do a similar thing over here, just select that part, duplicate it, move it up here to get the voltage on the collector. Wire that up. Now, that's not going to look terribly good, because when it prints the voltage is going to be up the top here and down the top there. I really want to take that part there and flip it vertically. That's better. Now that's okay for voltages. What about currents? Well, I can do a similar thing for currents. Bias annotation, place current marker. Now, for a current marker, you've got to place it on the pin of a component, otherwise it doesn't work. So I will place one on the collector of this transistor, and place another one. I can just do current marker on the base of this transistor, like so. And again, I'll have to rotate these so that the current becomes legible. If I run a simulation, then the currents and voltages will be worked out for all of these devices, and I can quickly do that by selecting Simulator, choose Analysis, DC Operating Point, OK, and then Simulation Run. And as you'll see, currently The base is at 689 millivolts, the collector is at 12.0976 volts, and it's difficult to see what the currents are because it's not putting the current values in a particularly sensible place. So we can move them. You move them by selecting the current probe, right-click, move text, value, and then put it somewhere more legible. And the same thing here. Oops. Must make sure to select only the current probe and not the transistor as well. And sometimes this can be tricky. Got it. Right-click, move text, value, and move it, say, around here. So you can now see we've got a base current of 9.56067 microamps, a collector current of 2.90245 milliamps, and the voltages are as shown. Fine. Save again, just in case.